versus a vector or a scalar? Anybody? Nothing? Magnitude? Anything? Okay. Pardon?
Like in science, when earthquake happens or something like that, it goes to magnitude.
Yes, it's on a magnitude scale. Why? What does magnitude measure? Nathan? Size, right. Magnitude is just a size. No direction, right? My height is a magnitude because my height is always my height, even if I lie down, right? Even if I'm on Jupiter, okay? So this is a magnitude. And this number in here is the distance from 0. So if I draw a number line, you don't need to draw it. There's 0, right? Where would you put positive 3? 1, 2, 3. Agreed? Yeah. How far is 3 from 0? 3. So the absolute value of 3 equals 3 because it's 3 steps away from 0. No direction. Now, if I go this way, where is that? How far is it away from 0? 3. So the absolute value of negative 3 is still 3 because it's 3 steps away from 0. Everybody cool? So they're kind of like brackets, but the answer you get in those brackets is always just how far it is from 0. So if I gave you this, what's that? 5, because 7 minus 2 equals 5, and 5 is 5 steps away from 0. Everybody cool? What if I changed it to this? It's still 5, because that answer is negative 5, and negative 5 is 5 steps away from 0. Everybody cool? Nathan. Whatever is inside these squares, the answer to that math is the distance away from 0. In this one, whatever you put in for x gives you that distance from 0. Okay? So let's do a table of values, shall we? Let's take a negative number, 0, and a positive number. Everybody okay with that? So let's take negative 2, 0, and 2. If I put negative 2 in for x, then I get y is the absolute value of negative 2, right? What is that? 2. X is 2 away, right? What's the absolute value of 0? 0, because 0 is no steps away from 0. What is the absolute value of positive 2? 2, because it's 2 steps away from 0, yes? Which gives me these 3 points. Negative 2, 2, yes? 0, 0, yes? And what's the third point? 2, 2. So let's graph them. Well, 0, 0 is easy to find, right? Negative 2, 2. Negative 2, 2. There's that one, right? And positive 2, 2. There's that one, right? Now, are there any squares or exponents in here? So this must make a straight line, right? Okay, so if I went up 2 over 2, up 2 over 2, right? It's going to continue on, isn't it? And it's going to give me that line. Agreed? Now, go this way. Up 2 over 2, up 2 over 2. I go this way. Why are there no negatives? Because you can't have an absolute value that is negative, right? So it's going to bounce off the y-axis. Now that's not the important part here. What the important part is here is look at this blue line. How many times that blue line hit the green line? Twice, which means there are 2 answers to this system. Does everybody understand? What are they? That is 6, 6. That is negative 2, 2. Now let's check. Is 6, the absolute value of 6, 6? Yes. Is the absolute value of negative 2, 2? So it's okay. What is half of 6? 3. Is 3 plus 3, 6? Is the absolute value of 6, 6? So even though the graph got funky, the intersections are still the answer. Does everybody understand me? So The point I'm trying to make is that, not to show you something new that will ever show up on a test, just to show you that even if you're graphing something that doesn't look normal, if the two lines cross, then that's a solution. Everybody good? So let me ask you this. Don't write this down. I just want to see if you're, paying attention. What if I had, and we've graphed these before, a parabola? We've seen them, right? Okay. What if I had a system of parabolas? Now, we have talked about systems of lines, yes, linear systems. Well, obviously, a linear system was two linear equations, right? So a quadratic system, or parabolas, must be more than one parabola. Agreed? So if I did this, oh, shoot, I want to use a different color. Where would the answer to this one be? Right there. Everybody cool? How many answers would it have? One. Excellent. What if I did this? Now it's going to have two answers. Agreed? What if I did this? Four answers. Everybody agree? Okay, what if I did this? Oop, I just lost my x-axis. Oops, that didn't work very well. One. Everybody cool? What if I did this? None. Everybody understand? Doesn't matter what the graph looks like. If the two lines cross, that's the solution. In grade 12, you're going to graph something that looks like this. Okay, that's called a sine curve. It has to do with trig. Now, if I had another sine curve that started out here, how many answers? What if I told you this went on forever? Infinite. But they would only show up in those two spots. Is everybody good? Sweet. Okay. Now listen, I'm going to do something a little weird here. I believe you that you're comfortable with graphing. All right? Number 8 and number 9 are really, really hard. I expect sometime tonight, as part of your homework, you try one of them. Okay? But because it's a short day, I'm going to go on to the next thing. All right? Because I believe that all of you can graph lines. The only thing that makes it difficult is when you read 8 and 9, you will see there's decimals and there's fractions, percentages. So it's not a new concept. It's just harder to do. Okay? All right. So if you could all flip to page, I don't know. I can't remember what's first. Is it substitution or elimination? Substitution. Okay. Now, this is an interesting thing for me because, as you all know, this is my 20th year of being a teacher. So I have taught math for a long, long time. The first time I ever taught Math 10, this was part of it. And I taught the kids how to do it. Now, if you look back at the first page of systems, it says there's 3 ways to solve these things. One is graphing, which we've already done. The second is substitution, and the third is elimination. Now, the first year I taught this, I taught substitution first. And the kids were like, oh, this is really hard, man. I don't really get it. And then I taught them elimination. And they all were like, why didn't you teach us this first? You're such a dink. And I was like, okay, it's my first time. I'm sorry, I'm new. So the next year, what did I do? I did elimination first. And guess what all the kids did, Tajvir? Oh, this is hard. I don't get it. And then I taught substitution. this is so easy. Why don't you teach us this first, dink? So guess what I did the third year? Reversed it. Guess what the idiot kids did? Oh, this is so hard. Why didn't you teach us elimination first? And I've been flip-flopping every year just to see if it actually makes a difference. Of course it does not. So when I finally decided to give up, I left substitution first because that was what I was taught first when I was 15. Okay? So now you're going to see this, and then some of you are going to be, tomorrow or Monday when I do elimination, you're going to be like, oh, this is so much easier, just to be funny. Yeah, no, you will. Hopefully it won't matter. So, right here I have all of the stuff you need to do. This is the last unit of Math 10, yes? You already could follow these instructions and solve this. You all already have the skills. So, let's work through it together, shall we? First step is going to be in red. Choose one equation and solve for one variable. What does this phrase mean in one word? What is the one word that explains that? Isolate. Nice job, Tushar. Woo! Isolate one variable. Does it say which variable? How do you know what a variable is in math? We use letters. Does it have to be a letter? Is this still a variable? 7 blank plus 3 equals 9? Yeah. So we could, anything that's not a number is a variable, right? Unless it's something like pi, because pi is a number. Everybody cool? So step one is isolate one variable. Doesn't matter which one. But I give you a handy hint. Choose one of the letters that's 1 or -1. Right? So, which of these are we going to work with? We're going to work with this one, yes? And our job, it says, is isolate for x. So what would have to happen here for x to be isolated? I would move the y. So this equation is now x equals 4y minus 1. Everybody understand? All right, now I'm going to switch to blue. Take the new equation. Where is the new equation? I'm going to highlight it. New equation, new equation. And substitute it into the other equation. What do you mean substitute? We've already spent 3 units doing this. What letter is that right there? Doesn't x equal 4y minus 1? So instead of writing 3x plus 5y equals 31, what do I write instead? Plus 5y equals what? 31. Now, is this the exact same thing? 3x and x is here. Does everybody understand this? And we couldn't have done it before because we had 2 unknowns, didn't we? But when we do this, what happened to that x down here? It's now a y. Do I have 2 unknowns anymore? I have 1 unknown. It's the y. Step 3, which I will do in green. Solve for the remaining variable. What is the remaining variable? Y. What does solve for y mean? Isolate y. So what am I going to do here? Expand that. What do I get? Minus 3 plus 5y equals 31. Now what? Collect like terms. What do I have there? I got 12y plus 5y. How many y's? 17y's minus 3 equals 31. Now what? Isolate y. So what's happening? Move the 3 over. 17y equals 34. Then what? By 17 to get y equals what? Which is? I'll wait. 2. And finally, in hot pink, Plug your solution into one of the original equations. Now let's stop and think for a second. We have a y value, right? So what is the value that's missing? X, right? Which of these three equations in our writing will give us x? Any of them, but one of them is set up nicely already, isn't it? Which one? The first one or the highlighted green one? Highlighted green one is going to give me x, isn't it? What letter is that? Y equals what? What letter is that? What can I put there? So doesn't x equal 4 times 2 minus 1? What is 4 times 2? Minus 1? 7. So now do I have an x and a y? So what's my answer? 7, 2. Should you ever say, Mr. Miles, did I do it right? Did I do it right? No, of course not. Why? Because you can check. We know we're right up here because we just did it, right? So what's the only one we got to check? The bottom one. What is 3 times 7? 21. Plus, what is 5 times 2? 10. Is 21 plus 10 31? So, kid, did you do it right? Did you do it right? Yes, you did. Super easy. Was there anything new? Algebra? Substitution. Have we done algebra this year? Yeah. Have we done substitution this year? Yeah. Because remember, in the last unit, x comma y, x, y, right? Let's look at the second one. Is this one ready to go? Not quite. I got to isolate something. What do you want to isolate? Y? Okay. So we're going to work with, I can't remember what color I used. Do I need the colors still or is everyone okay? I did each step in a different color. So we're going to work with this one, yes? What is it going to become? Now, might I suggest writing 3 minus 2x? Just so you don't have a negative at the front. So now, if that's y, how does that help us down here? What do I write now? Plus 3 equals 1. And then I just do grade 8 algebra, right? Let's do so. What happens with this bracket? So what is it? Now what? Not quite isolate. So what is 4 x's? Take away 6 x's. And where does that 9 go? To become what? What is 1 minus 9? Negative 8. What's my last step? Divide by what? Negative 2. What does x equal? 4. Now what? I have my x, so I know my answer is 4 something. Goes back to where? To the black one. Why should I go to the black one? Because y is already isolated. But could I go to either of these? Sure I could. Doesn't matter. But this one is already isolated, so I would do that one. And I would get y equals 3 minus 2 times what? 4. 3 minus 8. Negative 5. So what goes here? Negative 5. Do I know this one worked? I know this one worked, though. I just did it. So if this one worked, does this one automatically work? Yeah, so I really only need to check this one, don't I? Okay, so what is 4 times 4? 16. What is 3 times negative 5? Negative 15. Is 16 and negative 15 1? Kid, did you do it right? Yep. So easy, correct? Look at number 3 and tell me what's weird. There's no 1 to start with, is there? Damn, son! There's no coefficient of 1, is there? Is there? What do you see right there and there? They're the same thing. 4x equals 2 minus 5y, correct? If I move that over there? Well, if 4x is that, then what is this? 4x is this. So what can I write here instead of 4x? 2 minus 5y minus 20y equals negative 3. See that trick? Okay, who doesn't see what I just did? All right, we'll erase it. We'll do it again. We'll go slow. If you're memorizing steps, you're in trouble right now. What is the reason we do substitution? What are we trying to do? We isolate something, and then we move it into the other equation so we can get rid of something, correct? When we did this, x equaled this, right? And there's an x. Cool? Okay. So look here. You should see that those two are the same thing, aren't they? Okay. So if we were going to isolate just x, we would move this y, wouldn't we? Everyone agrees? Okay. So let's do that first step. We're going to move that y. 4x equals 2 minus 5y. Is everybody okay with that? Everybody that had their hand up, cool with that step? Okay. Now normally, I would divide by 4 so I could isolate x, correct? But I can stop here because 4x is this. What do you see right there? 4x. What is 4x? 2 minus 5y. So what can I write here instead of 4x? So I go 2 minus 5y minus 20y equals negative 3. And now, do I have only one letter? So now I can solve it. What would you do? Collect like terms. 2 minus 25y equals negative 3. Now what? Move the 2. What's going to happen to it? So negative 25y equals negative 5. Now what? Divide by negative 25, and y equals 1 over 5. Right? Because negative 5 divided by negative 25 is positive 1/5. Everyone agree? Yeah. Now, is y isolated? Yeah. Okay, so now what do we need to do with it? Apply it to where? Anywhere I see a y. Where's the best spot to put it? The red one, because what's going to happen when 1/5 multiplies by 5? It's going to become 1, isn't it? The 5s are going to cancel. So I will get, now here's the trick here. Is this x equals this? It's 4x equals 2 minus 5 times 1/5. Yes? What's going to happen to those 5s? Cancel. So 4x is going to equal 2 minus 1. What's that? 1. Then what's our last step? X equals what? 1/4. So what is my ordered pair? 1/4, 1/5. Kid, did you do it right? How do we check? Plugging it into which equation, Prab? Anyone we want, but which one would we use? Which one is set up very perfectly to get rid of a 4 and a 5? The first one. Because what is 4 times 1/4? 1. What is 5 times 1/5? 1. What is 1 plus 1? 2. Does it need to be 2? Yeah. Kid, did we do it right? Sure. Excellent. Everybody cool? All right. Now listen, I'm shutting up because that's it today. Have a look at the graphing stuff. Please notice I have only given you 8 questions with which to practice. And we've already done 3. And you've got the answers. Do you need to do all 8? Probably not. But notice the next page, I've given you a puzzle sheet with no answers. Practice a bit. This is a funny joke.
Do you like this one?
Yeah, I really like this one actually.
Is it better than the last one we did?
Why you got to be that way? I went through this whole book and chose the ones I liked the best. What are you saying to me?
You said you didn't like so much.
You're right. Some of them I don't like, but the rest of them are so much worse I had to leave them out. This one I actually like. I think this one is super funny. Everybody good? So, practice some graphing. Do you have to do a lot of it? No. Maybe 1 or 2. Try number 8 or number 9 because they're real hard. Tomorrow. Then do 1 or 2 or 3 practices. Now, let's say you do 2 and you get the answers right. Are you in pretty good shape? How would you know which one of these, do they all have a single letter? They all do, don't they? So these are all, no, there's a Y right there. So these are all going to be exactly the same, aren't they? Right? So if you can do 1 or 2 or 3 of them, you know you've got this nailed, yeah? But look on the next page. Are they all the same? Do they all have a single X or a Y somewhere? So they're all the same too, right? Everybody cool? By the end of this, you should be able to do substitution like that. But notice I've given you no extra practice on this type of one. Where will that show up? The test. Will you see some like it between now and the test? Of course you will. Where? In review or future homework or an assignment or when I say at the beginning of class some days like I always do this question. Everybody cool? Go. Yo. Of course you can.